So in the last video, we talked about how we can convert our model's prediction outputs, aka this long list of numbers that are really hard to understand if you're just looking at them for the first time, into something that we can understand, a predicted label in the form of a string. Well, what we want to do is to make it a little bit more visual, because this is pretty tedious, just comparing it like this. So we'll create some functions that are going to help us basically do this step, as well as visualize the actual image that a model is making a prediction on, and then compare it to that image's actual label, or the truth label. And just a little tidbit, these are also known as confidence intervals. If you hear them, this is a prediction probability. There's also confidence interval. So one methodology of evaluating a model is to go, okay, only give me the predictions that have a confidence value over 0.75. Every prediction that's max value is under 0.75 gets pushed to the wayside. Those are things you might want to pass to a human classifier, but everything over 0.75 you might want to let the model predict itself. Let's write a little note to ourselves. Having the above functionality is great, but we want to be able to do it at scale. And it would be even better if we could see the image the prediction is being made on. Part of being a data scientist or a machine learning engineer is not just being able to write this sort of code. A more important step than building a machine learning model is evaluating it. So this is what we're kind of doing. We're communicating to ourselves what's going on. Because it's one thing to just show someone an accuracy score. We could just go, yep, there you go. Our model's accuracy is 100% on the training set. And they might go, whoa, okay, let me see what's going on. So that's what we're doing. We go here. So if you had to report it to someone else, or if you had to show a colleague, or maybe your partner with a business who doesn't really know what you're talking about when you tell them the probability of prediction is 0.75, it's much easier when you can show them something visual. So we go here, note prediction probabilities are also known as confidence levels. Markdown, wonderful. All right, so a little function, let's go turn prediction probabilities, which is what we have up here. These are all probabilities. So if you hear me say prediction probabilities, I'm referring to a long array of numbers like this that are probabilities. And we go here, turn probabilities into their respective label. Easier to understand. So we'll go def get, we might do it of a single one. So maybe get pred label. We'll pass it a prediction probabilities array, which remember is just this. Prediction probabilities. Because what we're doing here, remember our goal is to just functionize this ugly print statement. Well, it's not really that ugly. It's actually some pretty neat code, but we want to make this available to us at scale. Prediction probabilities, yes. And then we want to leave a little docstring for ourselves. Turns an array of prediction probabilities into a label. We can just do a simple return statement here. Unique breeds. All we want to do is index the unique breeds for the argmax of prediction probabilities. Again, we're just replicating this one here. All we're doing is we just want the predicted label from this list of numbers. Let's see what that looks like. If we want to, let's get a little example. Get a predicted label based on an array of prediction probabilities. Typos galore. Pred label. Get pred label predictions. Let's go on the first index. So all we're doing, we're just calling our function, our beautiful little function that we've just written, and hopefully this returns us the pred label of 0. Border terrier, that's what we're after. 9. What's your favorite number? Mine used to be 81. Because 9 times 9 is 81, 1 plus 8 is 81, 8 minus 1 is 7. I have a dog called 7. And I had a Snorlax level 81 once. I traded it to a little American boy who was a mate of friends with at a resort. His name was Gareth, and he left the resort without ever trading back my Snorlax. So that was the end of that story. All right, wonderful. We've got a list of different predictions that our model has made, and we've got some functionality to turn those prediction probabilities into a label. So we're making our predictions more easier to evaluate for our eyeballs. We've already got some metrics on them with TensorBoard. Now what we'll probably do is, since our validation data is in a batch form, so it's a batch data set, we want to get a list, we want to unbatch it basically, because we want to rip out those images. So we want to get these images out of here and these labels, because these are the truth labels. That way we can make predictions on the validation images and then get our prediction labels using our function, and then compare those prediction labels to the actual validation labels. So let's make a small function which does that. So what we'll do, we'll go here. Now, since our validation data is still in a batch data set, remember it's in a batch data set because that's very efficient for TensorFlow to make calculations on. We'll have to unbatchify it, I just made that word up, to make predictions on the validation images and then compare those predictions to the validation labels, truth labels. This is going to be really cool once it's up and running. So let's write here, create a function to unbatch a batch data set. The people who make TensorFlow have actually thought about this problem. Well, not even a problem, it's just a little roadblock, because if you've batched a data set, surely there's a way to unbatch it, and there is. If we go TensorFlow 2.0, unbatch. Where is it? Dataset, unbatch. Unbatch, here we go. Splits elements of a dataset into multiple elements. For example, if the dataset elements are shape B, something, 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 where B may vary for, I'll let you read that if you want. But basically we've got elements here, TF dataset from generator, dataset.unbatch, list dataset as NumPy iterator. So once we've unbatched it, we can call as NumPy iterator, and it's going to turn it into an iterable list. So again, if this code doesn't make sense when you first read it, the best way to figure it out is to write it. So let's do that. Let's write it in a non-function first, and then we'll functionize it. So images, because we want to get the validation images, or we want to unbatch these. We want to get these and these into separate entities, not one. Labels, we'll make an empty list. Oh, maybe these are, I don't want to override a variable I have before. So images, we'll just underscore them. There we go. Then we want to loop through unbatched data. So we go image label, right? We've got a tuple here of image label. In val data.unbatch. So all I'm doing, calling unbatch. And I'm going to do these in one hit. So I'm going to call unbatch and dot as NumPy iterator in one hit. So let's see what happens. If we go print image, this might actually bust our computer, but we'll see it anyway. If in doubt, run the code. What's it going to return? Boom. So there we go. It's going to go, that's going to go for 200 or so, because that's how many samples are in our batch, our validation batch. But all it's doing now is printing out the image and the label. The image and the label. The image and the label. But the image is, remember, in the form of a processed image, a pre-processed image, which is that pre-processed image function we wrote right at the top. We don't want them just like that. We want to append them to our list of images. So append image and labels dot append label. So now what we should have If we go images 0, image is 0. So there we go. So there's one image. And its counterpart label, we should have just done that at the same time. Label 0. Why didn't that come out? Oh, that's why. Labels. See, confused myself with the variables that we're saving. This is why it's helpful to functionize things, because if you create different variables and you lose track of what variables they are, you'll confuse yourself. There we go. So there's the true label. So this is image validation 0 and its ground truth label. So our goal is to visualize this image and compare this ground truth label to the prediction label that it's made. So we could go get pred label, labels 0. Wonderful. Can't. What the prediction label was, so we could go get pred label, predictions 0. Border terrier. So that's a prediction that our model got wrong. So this is what we're trying to visualize. Right now, that's not really that fun, and we want to make things fun. So let's functionize this, and then we'll finish the video there. Actually, that's a challenge. Before I go off and start functionizing this little sequence, I want you to give it a try. Call the function something cool, like unbatchify, and it should take an input of a data set, a batch data set, and it should do this functionality and return these two lists. So that's your little challenge. I'll give you a couple of seconds. All right, I'm back. Didn't really leave, I was here the whole time. Hopefully you had a little try of functionizing this beautiful unbatchify function that we're going to write. So we'll write a docstring. Takes a batched data set of image label tensors and returns separate arrays of images and labels. Tick, tick, tick. And we want to create images. Because it's within a function, we can use whatever variable name we want. And then we're going to go loop through. So basically, all I'm doing is just rewriting this up here. Instead of copy pastoring, I'm just writing it out again because I want to practice. So for image label we only have to use data. So this is because I've set up a data parameter, so I can just pass it any batch data set I want. So data.unbatch as numpy iterator. Beautiful. Images.append image. Labels.append label. And then we can return images labels. If we test out our little functions unbatchify, let's see what your abilities are like, unbatchify. Do you stand up to the challenge of unbatchifying our validation dataset? Equals unbatchify. And we're going to pass it our val data batch. Exactly the same as what we've done here. We just functionized it. And we'll check out val images 0 and val labels 0. Boom. So just the exact same thing there. That's what we've got here. One final check is we can get pred label. What was it? Can or can, maybe I'm saying that wrong. If we go here, so get pred label, val images 0. Oh, no, it needs to be labels. Oh, did that? Okay. That worked. Oh, no. So that's going to work because that's numbers as well. So we actually want val label 0. Can't. Wonderful. Okay, so now we have a function for unbatchifying our data. We can get our validation images, which is great. So we can now work out some little functionality to make predictions on those images. We can get the ground truth label and then compare that to the prediction label. Let's delete this code here and we'll finish up the video. And in the next one, what should we do? We should make some functions to plot an image, so visualize an image of a beautiful little dog. We'll also compare the truth label to the predicted label. That sounds like a plan to me. I'll see you in the next video.